Hello, welcome to episode 146 in this series where I am programming an NES game from scratch. Tonight we are not live, but I want to try a different format of episode. You guys can tell me in the comments below or on Twitter at Clairvis or through Discord or Video Game Sage, whichever way you want to reach me. If you like this format better or not, let me know. We're going to do this for today's, and then you can tell me if this is good. And if it is, then we'll keep doing this. And if not, we'll figure something else out. I will stop bumping the microphone. So I wanted to work on some stuff. And I wanted to work on how to implement the ability to swap palettes in the level. And so I thought it would be good, a small enough chunk of work to do that, sort of off screen, but then record an after the process video, sort of it's not really a post-mortem because it's really short, but a review of the process versus showing you the whole thing live as I'm doing it. Maybe that makes more sense and is easier for you to work with. Maybe not. I don't know. Maybe people like watching me go through the whole process. Again, let me know what you think. So, all of that aside, what I wanted to do was I wanted to add a new type of object. So previously we had these spawn point objects. I wanted to add a new type that you could add. And so what I did was I created the ability to add a Paletteswap object. And the way that you do that is first I created a new object type called Paletteswap. I included the background color, palette value 1, 2, 3, and then this palette value, that's the index of which palette it is you're updating. So palette 0, 1, 2, 3, and then 4, 5, 6, and 7 would be the sprite palettes. So yeah, you'd be able to update the sprite palettes in the map too if you wanted to. Right now I only implemented that it updates palette 0, but that's okay for demonstration purposes right now anyway. So I'm going to create a new object. I'm going to do it pretty early on in the level so that we see it right away. And I'm going to plot that there, and we'll call that change palette. And then I'm going to change the type to Paletteswap. And so I want to leave the background value the same. I don't want to change that. I have screen tool open here. So 0F is what we're using for our background color. Let's change these three colors in that palette pretty drastically. So let's do 1.5 for the first color. And this is a string input, so I'm allowing the input of the hex value just for the sake of not having to do the conversions. It'll just keep it kind of simple. So I have 1.5, and let's do, I don't know, we'll do just kind of random colors. 2.7, and then, so that was this orange. Let's do something like this color 1C. And like I said, the actual palette that it adjusts is not settable right now. It's always just the first palette. So once you've set that, I changed the asset tool. So similarly to how we are processing the spawn points here, what we are doing is we are creating something where we check to see if the type is Paletteswap. And if it is, it will look for the properties and iterate through them, and it's going to grab the palette index, which again is not used right now. It's going to grab palette 1, palette 2, palette 3, and then the background. Now, one thing that I'm doing is I'm reusing existing values. I've created unions in this struct so that I can overlap the values without having to worry about additional storage. This is to both keep the storage minimal in the representation in memory, which is less important, but also to keep the representation minimal on the NES side, which is more important because fewer bytes is better if possible. So I'm storing the background color in the position X coordinate. The palette index is in the count because these values that I'm overriding or kind of overloading only make sense for something like the spawn point. They don't make sense for a palette swap, so it's okay to do this. The delay is overridden with P1, the sprite ID is with P2, and the sprite entity ID is with P3. So if we go back to this code, this is where we're writing it. It just reads in these values and stores them into the the corresponding locations. One thing that messed me up while I was working on this is that I didn't tell it to limit the value to a single byte, which is important because while that is a 16-bit, that is not, and that is not either. And that was causing some memory corruption, which was causing issues later on. So then we need to make sure that we don't overwrite the spawn entity ID because it doesn't matter for the palette swap. We're not using that. And then finally, when we're writing out the entity to the object file that has all of the objects that are part of a map, we just have to check to see if this is a palette swap. And if it is, then we don't want to convert the milliseconds over to a number of frames, which is what we were doing in this code in here. Again, that's only appropriate for a spawn point, so we don't want to change that because that will mess up the palette value that we're using. So going back to the map, we have this change palette here. As I mentioned last week, the map can be opened directly as the JSON file, so we don't have to export that. We do want to run this export process that generated all our files. So let's go back here and copy this and paste it in, and we'll replace that code, and then we can go to Visual Studio Code. I've actually implemented some of the tasks now so that we can do things from within Visual Studio Code instead of the command line. So I can run make directly in Visual Studio Code, and I can also run the project. I can run the game. I did create one for export, but that's not done yet, so I can't use that one yet. So I can either run the task directly, or if I do Control-Shift-B, it knows that that's a build task and will show that as a list, and you can see it, same output as when you run it from the command line. I can also type task build. Oh, actually, maybe I can't do that because it's a build task. All right. Well, anyway, so I mean, I can do that from Control-Shift-B, which is pretty handy. And then using Control-P, I can say task run. And you can see it brought up two things. It brought up grunt, and it also brought up run. So I'm going to click on run. I can hit enter also, and that will launch the ROM in Messen. And then once we get to that point in the map, let's bring up the PPU viewer. What we'll see is that that first palette will get swapped in, and I'll show how that works in the assembly code in a second. But once we get there, we should see these colors. Yep. Those colors got swapped, and you can see it was a pretty instantaneous change in the game. So that's pretty cool. And then we can do things like, I was messing around with this, we can make changes where we can actually do fades by staggering a number of these change palettes together. It's not the most efficient way to do it. We might want to do something where we implement a specific type called fade. But you know, it's a possibility where if we know what the palette is, we could manually fade it if that was something we wanted to do. So let's talk about how that actually happened. So there was nothing to do that was different in terms of how the objects are loaded from the ROM, because I didn't add any new properties, so I didn't need to change that process. But there was some new stuff that needed to get added to the game code in general. So one of the things we need to do is we need to create code to handle the palette swap. So if we go to, I created this file called paletteswap.asm, and if you look, I included that here with all of these other entity types that we process. In fact, that's something I should have brought up first. If you go to the project file, one of the new entities that I created was called Paletteswap, and so you may have seen it when I was doing this search. There is a new entity type called Paletteswap, and so in this process object loop where we're processing any object that's loaded in the object entities, it will look to see, is it a Paletteswap, and if it is, then it will jump to process Paletteswap. And this is something that just runs once because there's, again, it's not something that's continuously updating the palette. It's just a one-time update. We could change that if we wanted to do a fade over time or something like that, where we have some properties about how long it would take to fade and stuff like that. So I created this variable called reload palette because I don't want to have to check or actually forcefully reload the palette every time. I also created this 4-byte area for the new palette we want to load. I have to implement the code that works with specific palettes, because like I said, right now this only updates this first palette here, and I want to be able to update any arbitrary palette that I want from this object type. So for now it doesn't do that. It just sets this to be non-zero in order to indicate that we are going to need to reload the palette. And then it loads the values from the ROM for the new palette. So like I was talking about before, the background color is in the X position. The first color is in the Y world positions, low byte. The second color is in the data, low byte. And then the final color is in the Y velocity. And that was determined just by looking at the order in which these things were stored, and then also looking at things like, okay, so spawn sprite ID is also P2, right, with this union. Because for those of you who aren't familiar, I glossed over this a little bit before, but basically a union in C or C++ is saying these are two different identifiers for the same area of memory, and so they overlap. So if you change spawn sprite ID, you're changing P2 because it's essentially the same memory, just addressed in a different way. And the reason I do stuff like that is for the naming purposes, for naming conventions, so that it's, I'm referencing it as P2 when we're dealing with palettes and not spawn sprite ID, because that would be somewhat confusing. In the assembly side, I don't know, you might be able to do that, and if we are, we'll change this code to allow for that, but for now it's just referencing the structure names directly. So we load that into new palette plus 1, new palette plus 2, and new palette plus 3. So those are the 4 values for the palette update. And then we're just setting, I should really make this actually entity type, no entity, right? I believe that is the way that's defined. Should use the macro, or not the macro, the define instead of that's the wrong, what did I call it? Yeah, so entity type 0. That's a better way to do it, just in case for some reason that has to change. I don't have to worry about it being a problem. So then I store that into the type here to clear it out, and then I do my jump to get back to entity object complete because we're done processing this. So this runs once, like I said, where it updates this memory, and then it's done. And then the magic actually happens here at vblank. The reason that this happens here is if you try and update the palette while the game is running, depending on the state of the PPU and the game itself, it will not consistently or properly update the palette. Instead, it will create unexpected results for the palette updates. So in the gameplay state here, the first thing we do is we are checking this reload palette, and if it's branch of equal, if it's 0, meaning we don't care about reloading the palette, then just jump to here. Otherwise, we're going to 0 out the reload palette variable so that it is empty. We don't want to have to redo that. And then actually we can probably save a little bit there by doing transfer A to X, because A is 0, we know that. And then what we're going to do is we're going to read 2002 to clear the register latch for the addressing on the PPU, and then we're going to write 3F00. Again, this is hard-coded because we know we're always writing to the first palette. That will change when we move forward to allow arbitrary palette selection, but for now that's hard-coded. And then we just have a repeat of writing the palette values using X as our offset. So we write load new palette X, which is 0 the first time, and then we store it in 2007. So we update the first palette value, and then we increment X, and then we just use this little shortcut to have this happen 4 times because we know we're updating all the palette values, all 4 of them at once. And that's really it. If we rebuild this again, we can reload this here. And yeah, and again, you'll see that as soon as we hit the spot on the map, you can't see it here because there's too much in the way. This is too small. But as soon as we encounter that spot on the map, here it is, where we place that object to change the palette, it swapped the palette in, and we have the new colors in place, which is cool, and potentially may create some confusion depending on how you do it. Like in this case, then the background color doesn't match the map, and that's something to be to consider in terms of when you're doing these palette swaps. You have to make sure to consider what's on the screen, because then if you don't, then you're going to update things you don't intend to update. We can, we'll just have to be careful about doing that. But the fact that we can do this now is really cool. And then I can do something like, I can add another one here. And the X location doesn't matter. It's the Y location that matters. And let's do yet another color change. That's kind of crazy. Let's do 13 and 14. Let's just do 13, 14, and 15, right? So we'll save. We'll export this. Place. Run the make. And then reload. So we should get 2 different palette swaps here. Now we'll get the first one that we did, and then we'll get that second one, and you'll see the update happen here in the PPU window. There's the first one, and there's the second one. So there you go. Pretty straightforward. Again, not a whole lot that it was actually working on this time. I'll pick up on allowing any arbitrary palette to be updated. But it was just, I wanted to try this with a small amount of work and see what people thought. Because I didn't want anybody being too mad about missing too much. So anyway, that's it for this update. If you have any questions, you can reach me on Twitter at Clairvis. You can reach me on Discord, and under Video Game Sage as Zelius. On the forums there as well, you can reach me at zelius@gmail.com. Feel free to comment on this video on YouTube. I do have a Patreon, and buy me a coffee if you're interested in such things. But otherwise, I will see you all next time. I will try and do a live stream this week, although it will be a little bit busy for me, so I'm not sure when that'll be, if that'll be Thursday or not. But I hope you're having a good night and a good week so far, and I'll talk to you later. Thanks.